let's take a look at numbers 15 and 16. So like all previous examples, I'm gonna find an LCD, and then I'm gonna multiply each term in these rational equations by that LCD. Now taking a look at the factors in the denominators of number 15, I see an n plus 8, n plus 1. But over here in 16, I can see there's a GCF. If I were to factor out the r, the GCF of r, I'm gonna get r and r minus 2. So what that tells me is my LCD for number 15 is n plus 8 times n plus 1. But my LCD for 16, I need an r and an r minus 2, right? So I need to make sure I take that GCF out so I can see the individual factors. Like I have a linear factor of r and then another linear factor of r minus 2. Just to give you some extra vocab, right, we would call this a monomial, this is a binomial. But I just need to make sure each of those are represented in the LCD. And I always take the highest exponents I see in these denominators, and they all happen to be 1. Same thing over here. This is n plus 8 to the first, n plus 1 to the first. Okay, I'm gonna erase this. It's like always, we're just kind of jammed in here. So let me go ahead and multiply every term in this rational equation for number 15. I'm gonna multiply every term in there by the LCD, and things are gonna cancel. So I'm gonna have n plus 8, n plus 1, times n plus 5 over n plus 8. And that's going to be equal to n plus 8 times n plus 1 times 1. Plus, we'll have n plus 8, n plus 1 to that last fraction of 6 over n plus 1. And I'm just going to put a little separation here because I'm definitely going to need all the space I can handle when I get to number 2. Actually, you know what? Let me even just pause on that. I said number 2, I meant number 16. Let me see how much space I need. The 8s cancel, the n plus 8s, nothing cancels here. The n plus 1s cancel here. So I'm gonna have here n plus 1 times n plus 5. And for space sake, I'm gonna do the foiling now, just like I'm gonna foil these in a moment. So first is gonna be n times n, which is n squared. Outer is gonna be 5n. Inner is gonna be n, last is gonna be 5. That's going to be equal to, when I FOIL this, n squared plus, okay, outer is n, inner is 8n, last is 8. Here I'm going to just distribute the 6 to the n and the 6 to the 8. So that's going to give me 6n plus 48. And then it's a matter of let's collect like terms. I've got a quadratic equation, or at least it looks quadratic right now. So on this left side I have n squared, 6n, 5. On the right side, I only have the one quadratic term. I've got n, 8n, that's n, 6n. So let's see, n plus 8n is 9n. 9n and 6n is going to be 15n. And then 8 and 48, those are my constants. Those are going to combine together as well, and that's going to give me 56. So I've got a quadratic on the left, quadratic on the right. And maybe you can see, since I have an n squared here and an n squared here, if I were to subtract n squared, right, these cancel essentially. And I'm going to go ahead, subtract 6n, and then I'm going to actually move the 56 over here because I ultimately have a linear equation. So let's go see what we have. All right, 5 minus 56, if I crunch that number, that's going to leave me with negative 51. 15n minus 6n is 9n, so I'm almost done here. If I have 9n equaling negative 51, I just need to divide by 9, and my end game answer, I'm going to scrunch it right here. N is going to equal negative 51 over 9. That does not zero out my denominator, so I'll keep it. Okay, separation bar. Let's do the same thing here. So I'm going to multiply this LCD to this first fraction, to the number 1, to the second fraction. All right, r minus 2 times r plus 5. And instead of writing r squared minus 2r, I am going to write it out in its factored form. All right, minus r minus 2. This is going to equal r minus 2 times 1 over r minus 2. All right, so a bunch is going to cancel. Let's see what we're left with. The r's and the r minus 2's cancel. R's, r minus 2's cancel. So I have an r plus 5 here. I need to be careful in that I need to distribute the r. So I'm going to see this as r squared minus 2r, but I also need to distribute the negative. So it's actually going to be negative r squared plus 2r. So I just want to be careful when I'm doing all of that. I'm going to have an r plus 5. All right, -1 times r minus r squared. -1 times r times -2, positive 2r. And that's going to be equal to 1. So I'm starting to see I have a quadratic equation, right? I've got this -r squared. If I clean this up, I've got how many r's? 3 r's on this side. I've also got a plus 5. So let me clean this up, right? I've got -r squared. All right, r plus 2r is 3r. And then I have a 5 here, equals 1. Now, I could subtract the 1 from both sides, but personally, I like if I have a quadratic equation, I like when I have the lead coefficient that's positive. So I'm going to add the r squared. I'm going to subtract the 3r and subtract the 5. So I'm going to add r squared to both sides. I'm going to subtract 3r from both sides. And I'm going to subtract 5 from both sides. All right. Now I'm going to move that all over here. The r squareds cancel out. The 3r's cancel out. The 5 and the -5 cancel out by design. Right. So I have a 0. This is going to be equal to 1 minus 5 is -4. All right. Plus an r squared minus 3r. Let me clean this up. So I've got r squared minus 3r minus 4 is equal to 0. You can use the quadratic formula or you can factor. I'm going to go ahead and factor. This is going to be r minus 4 times r plus 1 is equal to 0 with the 0 product property. And I'll squeeze this in. Either r minus 4 is 0 or r plus 1 is 0. I think we can still maybe see that. Let me scooch my page just a wee bit over here so that you can see that. All right, I think we can still see that. I'm not sure. Even my view screen's a little wonky right now. So we've got from here, r is either 4 or -1. Neither of those zero out my denominators. So I'm going to go ahead and keep them. All right. Thanks so much, everyone. Bye.